Now, this one has a b value of 3 in there. I like to give these ones a name so that when we see them, we've got a name for these type of questions and then it can help you remember how to solve them. I call these ones multi-revolution questions. Okay, we can still use the same technique that we did before because this one has a period of 2 pi over 3. But what it does, in part A, we want to solve with x between 0 and 2 pi. Well, if x is between 0 and 2 pi, what will 3 x's be between? 0 and 6 pi. So we imagine going on around our circle, if we were going between 0 and 6 pi, that would be like going around our circle 3 times. So that's why I call it a multi-revolution question, because it's like going around the circle 3 times. And then afterwards, we're going to find out all the answers just if we went around the circle once. So if we're solving this first between 0 and 2 pi, oh, and there's no equal sign there, so there would be no equal sign on that part. And we had sine 3x equals 0. Well, is 0 on your pi plate? What values would you have? Right? If you were solving this, and now normally this is just x, or normally this is just theta, but now it's a 3x. So we say 3x equals, and sine is equal to 0 at 0 and pi and 2 pi. And that's only once around the circle. But we're saying we're looking for 3x between 0 and 6 pi, 3 times around the circle. So the first time around, you'd have 0, pi, and 2 pi. The second time around, you would also include 3 pi and 4 pi. And the third time around, you would have 5 pi and 6 pi, but I'm going to have to take out 6 pi just because there's no equal sign with the 6 pi. So for a multi-revolution question, you solve it as you would normally, but you're going to have to go around the circle a couple more times. Then, once you've got each of your answers, how would I get x by itself? I'd have to divide them by 3. So 0 divided by 3, I'd have pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3, and 5 pi over 3. And once again, you don't have to simplify that. 3 pi over 3, you could simplify that to be just pi, but you could leave it like that as well. So those are all the answers between 0 and 2 pi. For part B, it says find the general solution. And we stated in our steps, to find the general solution, you find all the answers between 0 and 2 pi. And we've done that in part A. And then all you would have to do is add 2k pi to each of those. So we can say that our general solution will look like this. X will equal 0, pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3, and 5 pi over 3. And you would go plus 2k pi for each of them. There is some repetition here, some stuff that we could do shorter. But on your final exam, if you would write it with all of those answers, that would be fine. Now, what Florian was saying before is we could look at just the period. So I'm going to show you another technique for doing this. You don't have to, you can choose whichever one. You'll never be asked to show one technique over the other. Both answers will be correct. I like what we did first because it follows the same pattern that we did for our previous ones, where you solve between 0 and 2 pi and then add 2k pi. And that connects to your coterminal angles, and it makes you think of your unit circle and say, okay, I have 1, 2, 3, 4, 5, 6 answers from 0 to 2 pi. I could take any one of those answers and add 2 pi, and that would hit every single coterminal one all the way through. Another way to look at this, though, is to say, well, if I was asked for the general solution of sine 3x equals 0, well, I would start by saying 3x equals, well, where's sine 0 from 0 to 2 pi? It happens at 0, and it happens at pi, and it happens at 2 pi. So I'm going to start with this. I'm going to make this even shorter after this. Okay? And if you had this, you would go plus 2k pi plus 2k pi plus 2k pi. That would be all of the answers so far, and that's what 3x would equal. Now at this point, if you wanted to solve for x, you could divide everything by 3. First of all, I want you to notice, before I go to the next step, that these two are the same. Can you see that? That 0 plus 2k pi and 2 pi plus 2k pi, they're saying the same answers because they're already coterminal, and I'm listing all coterminal angles. So when I divide by 3, I could cut one of those out, so I will. So I could get x by itself, and now I would have pi over 3 plus, and then you have to also divide your 2k pi by 3 as well. And the other one was just 0, so that would be 0 plus 2k pi over 3. Maybe I want to write this one. Oh, never mind. This would be this answer right here. This answer right here is exactly the same as this answer up here. Just takes a lot less space. So as far as things looking pretty go, the second method looks prettier. Okay? You might also note from here that I have 0, pi, 2 pi. It'll include 3 pi, 4 pi, 5 pi, 6 pi, 7 pi, any multiples of pi. So I could have also shortened this even further and imagined my 3x could equal k pi, where k is an integer. And then this as well is an even shorter version of the one that we had before. Okay, but you're not asked for the most concise version completely. You're just asked to provide a solution. And if your solution has more answers, it is still considered correct. So if we go back to our original steps that we wrote before, that idea was solve between 0 and 2 pi, like we did in A, and then you can just add 2k pi to each of those answers. If you want to think about your graph a little bit more intricate-wise, you can solve it as a general solution first by adding 2k pi to each of your answers, then divide by 3. That'll also work and make it a little bit shorter. And if you recognize the pattern that all the answers are of the form k pi, then you could write it even shorter. But again, I would just, if you're having trouble understanding this to begin with, I would keep with the strategy of solving between 0 and 2 pi, and then dividing by the number, or sorry, solving between 0 and 2 pi, and then adding 2k pi to each one. Questions you can do for this one? are 5, 6, and 10. I didn't give you any numbers with the first one.